Hello bachcho, welcome to JEENious classes. Today is our second class on this series, which is called your Cartesian product of two sets and relation. In my previous class, I have already discussed about what is Cartesian product of two sets, relation, as well as types of relation, and how many number of relations possible in each types. All I have discussed in my previous video. Those who have not seen my previous video, link has been given in the description box, so you can go there and check my first class. So in this video, we are going to discuss about mainly on problems. Problems based on Cartesian product of two sets and relations. Those who are new to my channel, please do subscribe and press the bell icon so that you get notified about all the new videos I upload in this channel. If you really like my class, don't forget to hit the like button and share it with your friends. Don't forget to comment me if you face any problem during my class. So let's start the class. यहाँ पर बच्चों क्या बोला है देखो, R is a इक्विवेलेंस रिलेशन ऑन आ गिवन सेट. कोई एक सेट है, उसके ऊपर आर डिफाइंड है, आर मतलब द रिलेशन डिफाइंड है, और वो आर इक्विवेलेंस है. इक्विवेलेंस है मतलब इट इज रिफ्लेक्सिव, इट इज सिमेट्रिक एज वेल एज इट इज ट्रांजिटिव. ये क्या है? आर इज दैट रिलेशन विच इज इक्विवेलेंस. अभी मुझे प्रूफ करना है कि आर इनवर्स is also an equivalence relation on the same set A. Is it clear? Okay. तो एक काम करते हैं, पहले हम लोग लेते हैं कि बोला है हमको कि R is an equivalent set, so I can say that R is reflexive. R is reflexive. Reflexive का मतलब क्या है? For all elements X belongs to the set. Let us say the given set be capital A. So for all X belongs to capital A, X comma X belongs to R. Is it clear? अच्छा बच्चों देखो, X comma X अगर R में है तो R इनवर्स में क्या होगा? इसका जस्ट ऑपोजिट. और उसका ऑपोजिट मतलब क्या बोल रहे हैं हम? अगर A comma B belongs to R, then we say B comma A belongs to R inverse, because that is the definition of inverse of any relation. So X comma X belongs to R implies X comma X belongs to R inverse. मतलब क्या हुआ? For all X belongs to A, X comma X belongs to R inverse. Therefore we can say R inverse is reflexive. हो गया? Okay. Now we have to prove that R inverse is symmetric. Let us assume that X comma Y belongs to R inverse. बच्चों सिमेट्री, एक रिलेशन सिमेट्री है, इसको प्रूफ करने के लिए मुझे क्या प्रूफ करना पड़ेगा? इसको प्रूफ करने के लिए मुझे यह प्रूफ करना पड़ेगा कि if X comma Y belongs to R, that implies Y comma X also belongs to R. Then we say that R is symmetric relation. यहां पर हम लोग लिए है X comma Y belongs to R inverse. तो मुझे क्या प्रूफ करना है? अगर प्रूफ करना है R inverse is a symmetric relation, so we have to prove that X comma Y belongs to R inverse implies Y comma X belongs to R inverse also. So now let us say as X comma Y belongs to R inverse, it means Y comma X belongs to R. Now as R is symmetric, because R is an equivalence relation they have said, so R is symmetric at the same time. So if R is symmetric, Y comma X belongs to R implies X comma Y also belongs to R. बोलो हाँ कि ना? और अगर X comma Y belongs to R है, then we will say Y comma X belongs to R inverse. So हम लोग क्या प्रूफ किया? XY अगर R inverse में है, this ordered pair XY, if it belongs to R inverse, that implies Y comma X also belongs to R inverse. Therefore, R inverse is symmetric. Clear हुआ? अभी क्या बचा है? Transitive. Let us say X comma Y belongs to R inverse and Y comma Z belongs to R inverse. Is it clear? These are the two ordered pairs which belongs to R inverse. मुझे ये प्रूफ करना है अभी कि this belongs to, this implies X comma Z also belongs to R inverse to prove that R inverse is transitive. Now observe carefully, because that is the definition of transitive relation. If A comma B belongs to R and B comma C belongs to R, that implies A comma C also belongs to R. Then we call that R is transitive. Clear? So, X comma Y belongs to R means what? I can say Y comma X belongs to R, and as Y comma Z belongs to R inverse का मतलब ये हुआ Z comma Y belongs to R. So now I can write in this way also. Z comma Y belongs to R and Y comma X belongs to R. बच्चों, R is an equivalence relation. इसका मतलब R is transitive as well. So we can say that Z comma X belongs to R also, because R is transitive. Now, as Z comma X belongs to R, this implies what? X comma Z belongs to R inverse. So what we have proved, XY belongs to R inverse and YZ belongs to R inverse implies X comma Z belongs to R inverse. Therefore, R inverse is transitive. Is it clear? So we have proved R inverse is reflexive, R inverse is symmetric, as well as R inverse is transitive. Therefore, R inverse is an equivalence relation on set A. Clear to everyone? Okay, let us move for the next problem. In this question, they have said, if capital R and capital S are two equivalence relations, let us assume that this relation is defined on set capital A. Let us assume for a time being. Okay? There is no harm in taking the set on which the relation has been defined as capital A. Now, as R and S are two equivalence relations, we have to prove that R intersection S is also an equivalence relation. Now, as R is an equivalence relation, it means that it is reflexive, symmetric, as well as transitive, both R and S. Now, for all A belongs to capital A, for all elements A belongs to the set capital A comma A must belongs to R. Why? Because R is reflexive. As it is an equivalence relation, it means that R is reflexive as well as S is also reflexive. It means A comma A belongs to R and A comma A belongs to S also. Is it clear? Now, A comma A belongs to R and A comma A belongs to S. It means that A comma A must belongs to R intersection S. R intersection S मतलब इसमें जो common elements है, दोनों में for all A belongs to capital A comma A belongs to both the sets. Therefore, their intersection of these two relations will contain the same element A comma A, right? So it means that for all A belongs to capital A, we have proved that A comma A belongs to R intersection S. It means that R intersection S is reflexive. No problem? Okay. Now we have to prove To prove that R intersection S is equivalence, we have to now prove that R intersection S is symmetric. Okay, let us assume A comma B belongs to R intersection S. It means what? A comma B belongs to R and A comma B belongs to S. Okay, now देखो बच्चों, R क्या है? R खुद एक सिमेट्रिक रिलेशन है, बिकॉज इट इज एन इक्विवेलेंस रिलेशन. इसका मतलब इट इज सिमेट्रिक है. अगर सिमेट्रिक है तो ए बी अगर आर में है तो गारंटेड बी कॉमा ए भी आर में है, एज इट इज सिमेट्रिक, एज आई हैव मेंशन्ड. एंड ए कॉमा बी एस में है, इसका मतलब ये हुआ बी कॉमा ए भी एस में है. क्यों? एस भी सिमेट्रिक है, राइट? So we can say that B comma A, it belongs to R intersection S. B comma A R में भी है, B comma A S में भी है. तो B comma A R intersection S में भी है. Okay, so what we have proved, A comma B अगर R intersection S में है, it implies B comma A belongs to R intersection S. It means R intersection S is symmetric. Is it clear? Okay, now we have to prove that R intersection S is transitive. So, उसके लिए हम लोग क्या बोल रहे हैं? हम बोल रहे हैं कि let us say A comma B belongs to R intersection S and B comma C belongs to R intersection S. अभी मुझे प्रूफ क्या करना है? What is our goal? Our goal is to prove that R intersection S is transitive. What is our goal? We have to prove that A comma C also belongs to R intersection S. ठीक है? तो इसके लिए हम लोग क्या करेंगे? देखो, A comma B belongs to R intersection S. इसका मतलब हुआ A comma B belongs to R and A comma B belongs to S and B comma C belongs to R and B comma C belongs to S. Is it clear? Okay. अच्छा, देखो बच्चों, ऐसे लिख सकते हैं हम लोग, A comma B belongs to R and B comma C belongs to R and A comma B belongs to S and B comma C belongs to S. Okay? So यहां से हम लोग क्या बोलेंगे? As R is transitive itself, because R is equivalence relation, so R तो transitive होगा, R भी होगा, S भी होगा, because S is also an equivalence relation. They have already mentioned in the question. So A comma B अगर R में है, B comma C अगर R में है, then as it is transitive, that is R, so we will say A comma C belongs to R. And A comma B S में है, B comma C S में है, और S मेरा transitive है, therefore we can write A comma C belongs to S. Therefore we will say A comma C belongs to R intersection S. So what we have proved, A comma B belongs to R intersection S, B comma C belongs to R intersection S implies A comma C belongs to R intersection S. Therefore we will say R intersection S is transitive. Clear? मतलब हम लोग क्या प्रूव किया? R intersection S reflexive है, symmetric है, as well as transitive है. Therefore, we will say R intersection S is an equivalence relation. Is it clear, बच्चों? एकदम. Okay. Next problem. यहां पर बोला है R and S are two equivalence relations. Same question. R and S both are equivalence relation. यहां पर बोला है prove that R union S is not necessarily an equivalence relation. Previous सब में क्या किया था? R intersection S वो मेरा equivalence relation है. कब? जब R and S both are equivalence relation. यहां पर क्या बोल रहे हैं? R and S are both equivalence relation, but it is not necessarily R union S will also be an equivalence relation. ये हम लोग prove करेंगे. So it is better to prove this given question by means of taking an example. Let us say A is a set of elements 1, 2 and 3. And R is a relation defined on A in such a way that R consists of the elements 1, 1, 2, 2, 3, 3, 1, 2 and 2, 1. Now look at carefully. R is very much an equivalence relation. Why? Because it is reflexive. Because all the elements of A are present here in their pairs. और क्या है? 1,2 है, इसका मतलब 2,1 भी रिलेशन में प्रेजेंट है, मतलब ये मेरा क्या है? सिमेट्रिक रिलेशन भी है. ओके, सो रिफ्लेक्सिव हुआ, सिमेट्रिक हुआ. अभी देखो बच्चों, 1,2 है, 2,1 है, देन अगेन 1,1 भी है, मतलब ये क्या हुआ? ये ट्रांजिटिव भी हुआ. मतलब R is very much an equivalence relation the way we have defined the relation here, right? Or mano S is another, the relation, let us define it something like this way. Say 2,3 and 3,2. Okay? Now the question ये है कि S क्या equivalence है? First है reflexive. देखो बच्चों, यहां पर for all the elements present in A, that is 1, 2, 3, their pairs are there in the relation S. Okay? मतलब ये क्या है? Reflexive है. 2, 3 है, 3, 2 भी है, मतलब ये क्या हुआ? ये symmetric भी हुआ. Okay. 2, 3 है, 3, 2 है, 2, 2 भी है, मतलब ये क्या हुआ? ये transitive भी हुआ. मतलब S is also an equivalence relation. Is it clear? So R equivalence relation है, S equivalence relation है. बराबर? Okay. Now you tell me what is your R union S? It is coming like 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 2, 3, 3, 2. ओके बच्चों, देखो यहां पर R यूनियन S ये क्या रिफ्लेक्सिव है? बिल्कुल है, क्योंकि फॉर ऑल एलिमेंट्स बिलोंग्स टू A, X, बिलोंग्स टू R यूनियन S, राइट? मतलब R यूनियन S ये रिफ्लेक्सिव है. सिमेट्रिक है क्या? लेट अस चेक. 1, 2 है, 2, 1 है, 2, 3 है, 3, 2 है, मतलब R union S is symmetric at the same time. Is it clear? मतलब ये रिफ्लेक्सिव हुआ, ये सिमेट्रिक हुआ. ये क्या ट्रांजिटिव है? Let us see. देखो बच्चों, 1,2 है, 1,2 है, 2,3 है. Yes or no? We are having 1,2, 2,3. अगर ये ट्रांजिटिव है, then 1,3 must present in this relation R union S. But unfortunately, 1,3 is not present in this relation. Therefore, R union S is not transitive. It is not a transitive relation. मतलब क्या हुआ? R union S is not an equivalence relation, though R and S both are equivalence relation. Have you understood this proof part? Okay, let us just move for now for MCQs based on relation and Cartesian product of two sets. यहां पर बोला है, देखो, let a non-empty set such that A cross A has 9 elements. A cross A में कितने एलिमेंट्स हैं? 9 एलिमेंट्स, which are found to be -1, 0 and 0, 1. मतलब जो कार्टेशियन प्रोडक्ट ऑफ टू सेट्स है उसमें 9 एलिमेंट्स हैं, जिसमें वो लोग 2 एलिमेंट चूज किया है, लाइक -1,0 एंड 0,1। ये दोनों ऑर्डर्ड पेयर उस कार्टेशियन प्रोडक्ट से सिलेक्ट किए हैं। अच्छा, अभी बोला है कि व्हाट आर द एलिमेंट्स प्रेजेंट इन सेट ए, राइट? बच्चों देखो, यहां पर मेरा सेट ए में क्या एलिमेंट्स रहेगा? यहां पर -1 है तो -1 तो रहेगा ही, 0 है, 0 भी रहेगा, क्योंकि ये कार्टेशियन प्रोडक्ट किसमें है? ऑन द सेट इटसेल्फ। ओके, मतलब ये जो 0 एलिमेंट है, ये एलिमेंट तुम्हारा ए में जरूर है। इसके लिए -1,0 इज वन ऑर्डर्ड पेयर चोजन फ्रॉम A क्रॉस A, and the other element will be, as 1 is here, so the other element will be 1 also. Therefore, your set A will contain -1, 0 and 1, ये तीनों element. Hence, option C is correct. Okay? See the second question. यहां पर बोला है A and B are two non-empty sets having n elements each. Having n elements in common. A और B दोनों सेट है, नॉन एम्प्टी सेट, जिसमें n एलिमेंट्स कॉमन है। अभी बोल रहे हैं कि देन द नंबर ऑफ एलिमेंट्स कॉमन इन A क्रॉस B एंड B क्रॉस A। ओके, चलो बच्चों एक काम करते हैं, इसमें हम लोग एक स्पेसिफाइड एग्जाम्पल लेके समझा रहे हैं। मानो A इज अ सेट ऑफ एलिमेंट्स 1, 2, 3, 4 एंड B इज अनदर एलिमेंट, लेट अस से 2, 3, 5। ओके, मतलब देखो बच्चों, A क्रॉस B में एक्चुअली मेरा कितने नंबर ऑफ एलिमेंट्स रहेगा? 4 3 is 12। लेकिन इसमें ऑब्जर्व करो, एलिमेंट्स 2 इज कॉमन, एलिमेंट 3 इज कॉमन। ओके, मतलब A क्रॉस B में जो एलिमेंट्स कॉमन है उसका साथ हम ऑर्डर्ड पेयर बना रहे। वो क्या होगा? 2 2 होगा, 2 3 होगा, 3 2 होगा, 3 3 होगा। बोलो हाँ कि ना? अदर एलिमेंट्स विल बी देयर, बट दीज आर द एलिमेंट्स which are the common elements of set A and B। वहां से हम लोग ये पेयर बनाए। ओके, पेयर जो हम लोग बनाए वो कैसे बनाए? ये कॉमन एलिमेंट से। मतलब मेरा B क्रॉस A में जब हम बनाएंगे, B क्रॉस A में भी 12 एलिमेंट्स रहेगा, लेकिन उसमें देखो 2,2, 2,3, 3,2 and 3,3. These 4 elements will be guaranteed present in A cross B as well as B cross A. Other elements will not match, but these are the elements which will definitely match in A cross B as well as B cross A. मतलब मेरा यहां पर देखो बच्चों, 2 एलिमेंट कॉमन था, और मेरा A क्रॉस B और B क्रॉस A में जो कॉमन एलिमेंट्स आया है वो है 4 एलिमेंट्स, राइट? मतलब इट इज कमिंग लाइक 2 स्क्वायर। ओके, अभी देखो इसको अगर हम जनरलाइज करें कि A और B 2 नॉन एम्प्टी सेट्स है, जिसमें एक दोनों सेट में n एलिमेंट्स कॉमन है। इसका मतलब यह हुआ A क्रॉस B एंड B क्रॉस A में n square elements will be common. Is it clear? Hence option C in this case is correct. Right? Let us take another problem. यहां पर भी देखो सेम क्वेश्चन दिया है। A and B are two non-empty sets having 3 elements in common. A में कितना है? What is the cardinal number of A? It is 5. And what is the cardinal number of B? It is 4. मतलब A क्रॉस B या B क्रॉस A में टोटल 20 एलिमेंट्स रहेगा, लेकिन कॉमन एलिमेंट्स कितना रहेगा? क्योंकि दे हैव आस्क्ड फॉर व्हाट इज द A क्रॉस B इंटरसेक्शन B क्रॉस A। इसका मतलब क्या हुआ? A क्रॉस B और B क्रॉस A में जो कॉमन एलिमेंट्स है वो कितना होगा? नेचुरली जस्ट नाउ वी हैव डन, इट इज n स्क्वायर। मतलब जितना एलिमेंट्स मेरा कॉमन है उतना का स्क्वायर विल बी द कॉमन एलिमेंट्स ऑफ A क्रॉस B एंड B क्रॉस A। यहां पर 3 एलिमेंट कॉमन बोला है, मतलब A क्रॉस B एंड B क्रॉस A में कॉमन कितना रहेगा? 3 square which is equals to 9. Hence option D is correct. Is it clear? देखो बच्चों नेक्स्ट प्रॉब्लम यहां पर बोला है A क्रॉस, यहां पर क्या बोला है A क्रॉस B कॉम्प्लीमेंट यूनियन C कॉम्प्लीमेंट का होल कॉम्प्लीमेंट। बच्चों हम लोग को डी मॉर्गन्स लॉ पता है। व्हाट इज डी मॉर्गन्स लॉ? इसमें क्या बोलते हैं B कॉम्प्लीमेंट यूनियन C कॉम्प्लीमेंट का होल कॉम्प्लीमेंट विल बी इक्वल्स टू B कॉम्प्लीमेंट का कॉम्प्लीमेंट इंटरसेक्शन C कॉम्प्लीमेंट का कॉम्प्लीमेंट। मतलब क्या हुआ B इंटरसेक्शन C। मतलब मेरा जो क्वेश्चन है ये क्वेश्चन अभी क्या किस में बदल गया देखो B इंटरसेक्शन C। ओके इसको हम लोग प्रॉपर्टीज में सीखे हैं। कार्टेशियन प्रोडक्ट ऑफ टू सेट्स का जो प्रॉपर्टीज है उसमें हम लोग सीखे हैं कि इसको हम लोग लिख सकते हैं A क्रॉस B इंटरसेक्शन A क्रॉस C। मतलब मेरा ऑप्शन B इज करेक्ट, आई एम सॉरी A इज करेक्ट इन दिस केस, राइट। चलो नेक्स्ट प्रॉब्लम देखते हैं। इसमें क्या बोला है इफ अ रिलेशन R इज डिफाइंड ऑन सेट Z मतलब सेट ऑफ इंटीजर्स जिसमें A स्क्वायर प्लस B स्क्वायर है क्या 25। अभी बोला है व्हाट इज द डोमेन ऑफ R। मतलब देखो बच्चों डोमेन ऑफ R मतलब क्या है ऑर्डर्ड पेयर में फर्स्ट कोऑर्डिनेट इज द डोमेन ऑफ दैट रिलेशन, राइट। सो यहां पर हम लोग को करना क्या है हम लोग को निकालना है व्हाट इज माई A। बिकॉज रिलेशन में मेरा ऑर्डर्ड पेयर क्या है A कॉमा B। So A is the first coordinate and the first coordinate is nothing but the domain of that relation R. Okay. So यहां पर A मुझे निकालना है। How to find out A? The relation which is given is A square plus B square is 25. So A can be written as A square equals to 25 minus B square. That implies A is root over 25 minus B square with a plus minus sign. And A and B will all take integers. Remember this. Now you see, if I take B as 0, we are getting A as plus minus 5. Both are integers. Okay. Now if I take B as 1, you are not going to get any integers. If I take B as 2, again 25 minus 4, that gives us 21. Root over of 21 will not give you an integer. Therefore, B equals to 2 I am neglecting. So let us take B as 3. If I take B as 3, so A is coming to plus minus root over 25 minus 9. That is coming like root over of 16. That is plus minus 4. Which both are integers. When B is 3, A is plus minus 4. Both are integers. So we can take those values. Now if I take B as 4, then we are getting A as plus minus 3. That is also accepted. If I take B as 5, then we are getting A as nothing but 0. Okay, which is also an integer. The first coordinate of the ordered pair AB will be 0, plus minus 3, plus minus 4, and plus minus 5, right? So these are the first coordinate of the ordered pair A comma B. Therefore, the domain of the relation R is nothing but 0, plus minus 3, plus minus 4, and plus minus 5. Hence option C is correct for this problem, right? Let us take another one. यहां पर देखो क्या बोला है modulus of A minus B is less than equals to 1. This is the relation defined on set Z of integers, right? It is defined on the set of integer Z. Now they have asked for whether this relation is reflexive, symmetric or transitive or equivalence. We have to find out that. So first of all, let us check for whether the relation is reflexive or not. So for that, what I will say, for all X belongs to Z, for all integers belongs to the integer set Z, x comma x belongs to R. You know why? Why it is so? Why I have written it? Because if x comma x belongs to R, it means what? It must satisfy this condition. Now, mod of x minus x, that will give you what? 0. And 0 is obviously less than equals to 1. Is it clear? So, for all x belongs to z, x comma x belongs to R. It implies that R is reflexive. Is it clear? R is reflexive. Fine. Now, let us say A comma B. Let us say x comma y. This belongs to R. It means what? It means that modulus of where x and y both belongs to z. Okay? So, modulus of x minus y, this will be less than equals to 1. Why? Because as xy belongs to R, so it has to satisfy this condition. Now, from here we can write y minus x. Since there is a modulus sign, so your taking minus sign common will not affect the inequation. Is again less than equals to 1. It implies y comma x belongs to R. It means what? If x comma y belongs to R, that implies y comma x also belongs to R. Hence we will say that R is symmetric. Is it clear or not? R is symmetric. Now we have to check. So it is reflexive, it is symmetric. Okay? So option B, we are getting it. Right? Option B is already we have decided that it will be the right answer. But now we have to check whether it is transitive or not. Let us check it. Let us say 5, 4 belongs to R. And 4, 3, it belongs to R. 5, 4 belongs to R. Why I have said this? Because mod of 5 minus 4, that will give you 1, which is less than equals to 1. 4 minus 3 belongs to R. It means modulus of 4 minus 3, which is again coming to 1, which is less than equals to 1. मतलब ये दोनों condition is true. 5, 4 belongs to R and 4, 3 belongs to R. That implies if it is transitive, 5, 3 must belongs to R. But you see, 5, 3 does not belongs to R. Why? Because modulus of 5 minus 3 is 2, which is not less than equals to 1. Hence, the relation R is not transitive, right? Hence, option B is correct, right? Chalo, next problem. In this problem, we have been given that your set A contains the element 1, 2, 3 and 4, and the relation R is defined in such a way that it will have the ordered pair A comma B if modulus of A square minus B square is less than 16. Now let us assume that A is 4. If A is 4, B can take all the values 1, 2, 3 and 4. Think about it. Because everywhere your modulus of A square minus B square will be less than 16. When A is taking the value 4 and B is taking the values 1, 2, 3 and 4. Any value you choose, it will be always the square of the difference between the square of these two will be always less than 16. Therefore, the elements that will come in R are 4, 1, 4, 2, 4, 3 and 4, 4. Right? Okay. Now let us assign A with the value 3. Now if A is 3, look it carefully, your B can again take the value 1, 2, 3 or 4. Why it is so? You see, if A is 3, then it is basically 3 square minus B square less than 16. Now, if I take B as 1, it will become 3 square minus 1 square, which is less than 16. Again, if I take B as 2, it will give you 3 square minus 2 square is less than 16. If I take B as 3, then it will be 3 square minus 3 square, which is 0, which is again less than 16. Now, if I take when A is 3 and B is 4, then it is coming like 3 square minus 4 square, which is actually giving you 9 minus 16, that is minus 7. But since there is a modular sign, so it will not affect the absolute value. The absolute value will be what? 7. So again, 7 is less than 16. That is why I told you when A is assigning the value 3, B can take the value 1, 2, 3 or 4. Therefore, the elements that will come in R are 3, 1, 3, 2, 3, 3 and 3, 4. Is it clear? Now if I assume in A as 2, then also again, B will take the values 1, 2, 3 and 4 with the same argument that I have given you right now. Okay. So again, the elements that will come are 2, 1, 2, 2, 2, 3 and 2, 4. Now you see, if I take A as 1, in that case also your B can take the value 1, 2, 3 and 4. Therefore, the elements that will participate in relation R are 1, 1, 1, 2, 1, 3 and 1, 4. Is it clear? So your relation R will contain these elements. Is it clear? Now we can see that none of these options are matching with our answer. Hence option D is correct. Okay? Chalo, let us take the next problem. See, the relation R given here is 1, 1, 2, 2, 3, 3 on the set 1, 2, 3. Now we all know that any identity relation is reflexive, symmetric as well as transitive. That is, in one word, you must remember that any identity relation is an equivalence relation. Clearly, your R is an identity relation in this case. Hence, R is nothing but an equivalence relation. Hence, option D is correct. Next problem. Here, the R relation is given over here, and the set on which the relation is defined contains the element 1, 2, 3 and 4. Now observe carefully, we are not having 1, 1, 2, 2, 3, 3 and 4, 4 as elements in set R. Hence it is not a reflexive one. So this option is wrong. Now is it symmetric? Let us see. 1, 3 is there, 3, 1 is there, 4, 2 is there, 2, 4 is there. But 2, 3 is present in R. We are not having 3, 2 present in R. Hence, it is not a symmetric one. Hence, option C is correct. But still, we will check whether it is transitive or not. देखो बच्चों, यहाँ पर 4, 2 is present. 2, 4 is present. Now, if R is transitive, 4, 4 must present in R. But 4, 4 is not present in your relation R. Hence, it is not a transitive one. Is it clear? Now, we have to see whether it is a function or not. Look it carefully. We are having two sets of the same set A, which is 1, 2, 3, 4. And 1, 2, 3, 4. In the relation, whatever we have given, let us just map it by an arrow diagram. We are getting 1 is mapped with 3, 4 is mapped with 2, 2 is mapped with 4, 2 is mapped with 3, and 3 is mapped with 1. Now observe carefully, your element 2 has two images in set A. I mean, in this set, we are having two images of the element 2, right? Which violates the condition of a function. Hence, it is not a function. Therefore, our correct option is not symmetric. Hence, option C is correct. Is it clear? Okay. So this problem. Here they have said that the cardinal number of A intersection B complement is 9. It means what? Cardinal number of A minus cardinal number of A intersection B is 9. Moreover, we have been given cardinal number of A complement intersection B, which is equals to 10, implies NB minus NA intersection B equals to 10, right? This we have all done in sets lecture. Now, if I add this two, if we add this two, we are going to have NA plus NB minus 2 times NA intersection B is 19. Correct? But we have been given here that N of A union B is 24. N of A union B is 24. It means what? NA plus NB minus NA intersection B is 24. So from this equation we are having 24 minus N of A intersection B is 19. So number of elements in A intersection B is 24 minus 19, that gives us 5. Right? Abhi bachcho dekho, what is the cardinal number of A then? From this equation, we can say NA minus 5 is 9, implies NA is 14. And from the second equation, we are getting NB as 15. Correct? Therefore, cardinal number of A cross B is cardinal number of A into cardinal number of B. So that gives us 14 into 15, that is equals to 210, right? Hence option B is correct. Is it clear to all of you? Absolutely? Okay. So let us end our class here. If you are new to my channel, please do subscribe and press the bell icon. And don't forget to hit the like button if you have really liked my class and share it with your friends. Don't forget me to comment in the comment section if you have faced any problem during your class. We are having our learning app. You can download it from the Google Play Store. Link has been given in the description box. There I used to come twice a week live. So if you have any doubts regarding mathematics, you can ask me there and it's all free. So keep learning, keep watching and stay tuned to us.